Okay, so we're going to start our new section, 6.1. This is going to be talking about radians, so we're finally going to start getting to use the radian buttons. So looking at your unit circle, really quick, let's just talk about where those would be located. So here's like 30 degrees, which in radians would be pi over 6, 45 degrees would be pi over 4. So all of these inside that are in pi, that is your degrees in radians. So what we're going to do today is we're going to figure out how to calculate those. And the important part is going to be right here. So 1 radian is equal to 180 over pi. And 1 degree is going to be the opposite. We're just going to flip it, pi over 180. So depending on what they want us to change or convert these to and from will determine which one of these we're going to use. Okay, so let's look at this first one. If we start out with 330 degrees, and for right now, you're going to be able to check this on your unit circle. So yeah, I agree, I can look at my unit circle and know that my answer is going to be 11 pi over 6. So right now that's going to be a good way to check it. But these are going to start getting bigger and bigger, and you're going to want to just be able to use these conversions. So I have 330 degrees over 1, and every degree is worth pi over 180. So times pi over 180 degrees. Okay? A lot of times what I will do here is I will cancel from the beginning because I'm not a big calculator user, and I probably would even cancel here again, but I'm just going to go ahead and write it. 33 pi over 18. I do know that 3 is going to go into each of those the same, so 11 pi over 6. All right, so I can, again, go to my unit circle, go to 330 degrees, and I'm going to see this is in radians, okay? If this messed you up, go ahead and just do 330 pi all over 180 degrees. You cannot just throw this into your calculator and have a decimal. It needs to be written in fraction form, okay? So don't just jump straight to the calculator, throw it in your calculator, and be done. All right, so let's look at this next one. This time we're going the opposite direction. So I have 2 pi thirds radians. Now if I go to my unit circle, I can see that that's at 120 degrees. If you go to your unit circle, find 2 pi over 3, it's at 120 degrees. So if I don't get that answer, I've done something wrong. So every radian is equal to 180 over pi. So I'm going to multiply this by 180 over pi, okay? Pi's are going to cancel. 3 goes into 180 60 times. 60 times 2 is 120 degrees. Okay. If I lost you there, you can always do it the long way. 2 times 180 is 360 pi, because you had pi on top, times 3 pi on the bottom. The pi's cancel. 3 goes into here, 1, 2, 0, 120. Okay, so it's whatever is easiest for you. All right, so let's look at the next one. Let's look at number 2. So they are wanting us to evaluate cosine at 4 pi over 3. Okay, so there's a couple different ways. If it was me, I would go to my unit circle. I would locate 4 pi over 3, which is at 240 degrees. So this is at 240 degrees on my unit circle. On my unit circle, those coordinates are negative 1/2, comma, negative root 3 over 2. They asked me for cosine. The coordinates are written in cosine, sine. So cosine would be negative 1/2. So this is equal to negative 1/2. Now, the other thing you can do is we can take this and convert it, get 240 degrees, put that into our calculators, or I can just go to my unit circle, find 240 degrees, and voila, there it is. Okay, so this is just kind of different ways of using our unit circle. All right, let's look at the next part. Okay, so the next part we're going to do is we're going to find arc length. So when we talk about arc length, we would be talking about, in this picture, make sure I have all in there, would be the length from D to C. Okay, that would be the arc length. A to B would be the same thing when we're talking about arc length. So, oops, all right, here would be my notation. When they have M, that's the measure of. Instead of angle, we're going to talk about arc AB. Okay, that was that one over there. And arc C to D. Okay, we're trying to figure out how to find those. Basically, we're going to just use this formula. So this formula right here is going to be extremely important. Arc length is what S stands for. So this is arc length. R is what we've been using from the beginning of time since geometry. That is the radius. The only thing that's going to be a little bit new here is theta. And the reason I say that is because theta has to be in radians. That's the measure of the angle in radians. We cannot throw degrees in there. This must be in radians. Okay? So, with that being said, let's move down here to example number 3. All right. So given that the central angle, okay, is 128 degrees, find the length of the intercepted arc. So what they're wanting to know is this distance from here to here. They tell us that the radius is 5. Okay, so here's our radius. And they want to have this to the nearest tenth. So here we go. S equals R theta. So arc length equals the radius, which was 5, and theta has to be in radians. So the first thing I need to do is convert 128 degrees into radians. And earlier we knew that 1 degree was worth pi over 180. Okay? Now, if you want, you can just fill that in. If you don't want to do any simplifying, you can always just throw in 128 pi over 180 and go from there. If you want to simplify here, obviously those are both even numbers. You can simplify. It's up to you. Right off the bat, I know that 5 is going to go into 180, 30, let's see, 15, that's another 30, so 36 times. So now I have S equals 128 pi over 36. Let's see. Those are going to reduce by 2. So 64 pi over 18. Those are going to reduce again. 32 pi over 9. Okay. It does say to round to the nearest tenth. If I'd have been paying attention, I could have saved a whole lot of time. So, if you think you've reduced wrong, go right here. So what we're going to do is we're going to do 128 pi, and there is a pi button on here somewhere. Where's it at? There it is. The pi button is right here. So I hit second pi, so 28 pi divided by 36. 11.17. Okay. Round to the nearest tenth. And that would be in centimeters. Okay. Since we're only finding a length, not an area, it's just centimeters, not centimeters squared. All right, let's look over on the back. Let's go to the next one here. All right. Okay, short and sweet. This is just wanting to know the distance between the two cities. So it just wants to know the distance, see that, between Winnipeg and Dallas. We're only looking for this. Well, the entire distance from here to here is 50, and here is 33. So we just need this distance. So 50 minus 33, 17. 17. Okay, so this right here is going to be 17 degrees. Does it tell us our radius? Yes, our radius is in the reading right here, quite a bit. All right, so S equals R theta. Okay, we have to change 17 degrees into radians. So 17 times pi over 180. So basically, I'm just going to plug that in. So S equals our radius, which they gave us, 3960 over 1, just to make this a little bit cleaner, 17 pi over 180. So S equals, we're going to take 3960 times 17. So I get 67320 pi over 180. So I can take that times pi divided by 180. So 1,174.95. So if you were going to round that up or round to the nearest, they don't ask us to do anything specific. So I would just leave it at that, miles. Okay, pretty easy, pretty short and simple, short and sweet. Let's look at the next one. Okay, the next part is a sector. So basically, sector is a fancy word. Just think of it as a slice of pie. Okay, so basically it's like a slice of pie. It's like if I cut this little piece out, I want to know this entire area for just that slice that I took out. So here is going to be, okay, here's going to be that. That's my formula. R is still going to be my radius. Theta is still going to be in radians, so measure of the angle in radians. Okay. And we're basically just going to plug and chug and just use this to our advantage, this whole thing right here. So they give us this picture. They tell us that the sector of the central angle measures 5 pi over 6 radians, which is awesome. We don't have to do any conversions. They've already given it to us in radians. That is my theta. And that the radius is 16. So basically, they've done all the work for us. So the area is 1/2 r squared theta. All we gotta do is start plugging it in. So 1/2, the radius is 16. I'm just gonna put all of these on top and bottom so that we don't get confused about what's going where, times the theta, which is 5 pi over 6, okay? So from here, we have everything on top, everything on bottom. We cannot do any cross-canceling or anything because we have an exponent here. So the first thing we need to find out on top, we're just going to take everything across the top. So 16 squared times 5. I'm just going to leave the pi to the end. So 1280. So I have 1280 pi over 2 times 6 is 12. Okay. From there, they're asking me to round to the nearest tenth. So I can take my answer times pi, divide it by 12. And I'm getting 335.1. So 335.1. Round to the nearest tenth, because it was 1, 0. That is to the nearest tenth. And this would be in, our only measure of units is centimeters, and since I'm finding area, it would be centimeters squared. Okay. This is pretty short and sweet. There's really no tricks to this. It's as easy as it kind of sounds. You are going to do for tomorrow page 438 all.